Welcome again, guys. The last couple of days in class, we've been focusing on how ions are made and naming ionic compounds. What we're going to do today is we're going to put those two pieces together to go ahead and learn to make ionic compounds from the name. Because not only do we need to be able to name ionic compounds, we have to be able to look at a name and figure out what the formula is. So a couple of hints for you to keep in mind. First and foremost, your ionic compound must have a net charge of 0. So when you look at the total positive and the total negative, they must cancel each other out because we know ions are made by atoms gaining or losing electrons. So the number of electrons that the metal wants to lose has to equal the total number of electrons the nonmetal wants to gain. And when you do that, the charge equals 0. So that's the most important part. When you're making ionic compounds, the total charge must equal 0. When you're looking at the periodic table trying to figure out ionic charge, remember the metals coming from 1A, 2A, and aluminum always make the same positive charge. 1A is always plus 1, 2A is always plus 2, and aluminum is always plus 3. That's going to help you figure out the ionic compound. Your nonmetals in 5A, 6A, and 7A also make a constant charge. 5A is always minus 3, 6A is always minus 2, and 7A is always minus 1. And remember, those numbers come from the idea of trying to make the atom octet happy. So it's either going to lose or gain electrons based on how much it needs to become octet happy. Your transition metals, remember, make a varying charge. So you can either use the anion to help you determine the charge, or you can look at the name. Because remember, the name will always have Roman numerals in parentheses. So if you saw a 2 in the middle of a name, that would equal a plus 2 ion. Where if you saw 3 in the middle of a name, that would equal a plus 3 ion. So those Roman numerals in the middle of the name can help you figure out what the total charge is. And if you're dealing with a name that has a polyatomic ion present, you can use the back of your periodic table to determine the charge and what the compound looks like. So remember, if you're looking at a name and you see something that ends in ate or ite, that means you have a polyatomic ion. So flip that periodic table over and look at the back. Let's try a couple of examples. We're going to go ahead and we're going to start at this second guy here, this magnesium chloride. Let's really talk about what's happening when an ionic compound is actually made. So if we look at magnesium, we know that that means we're dealing with the element Mg, and chlorine is what the chloride is made from because we changed the IDE ending with the anion name. So we know we're dealing with the elements Mg and Cl. So let's go ahead and let's look at how this ionic compound is made. We know that magnesium comes from the second column, so it has 2 valence electrons that it wants to lose to become octet happy. Our chlorine, oh, I don't want to use blue, it's going to get lost up there. That was silly Etnire. Let's use purple. All right, my chlorine comes from the 7th column, meaning it only needs 1 more electron to be octet happy. So if we look at the magnesium, it has 2 electrons it wants to lose, but this chlorine atom only wants to gain 1 electron. So the magnesium can transfer its electron to the chlorine, making the chlorine a -1 atom and totally octet happy. But the magnesium is not happy, and this comes down to the idea that the magnesium and the chloride do not have equal charges. We know that Mg makes a plus 2 ion, where chlorine makes a -1. So if I just put 1 magnesium and 1 chlorine together, it does not equal a net charge of 0, because positive 2 and negative 1 would actually equal positive 1. So I can't use just one of each of these pieces. I would need to use more of one of them. Since my magnesium has 1 more electron to lose, and my chlorine wants to gain 1 electron, I can bring another chlorine atom to the party. And he can take on this other electron that the magnesium wants to lose. So that makes it a -1 ion. And since my magnesium has lost both its electrons, it's a plus 2 ion. So what that tells me is my magnesium has lost 2, each chlorine has gained 1, and so in order for me to make this ionic compound with a net charge of 0, I only need 1 magnesium, but I need 2 of my chlorines. And I use a little subscript 2 to show me that there's 2 of those ions present. So anytime you see that little subscript, that tells you how many of that atom you have. Now, is there an easier way than drawing these pictures? Absolutely. If we look at magnesium plus 2 and chlorine plus 1, what we want to look for is the least common factor between those two numbers. So the least common factor between 2 and 1 is 2. I can simply just take my -1 and multiply it by 2, and that would get me to a -2. So my +2 and my -2 would cancel each other out. So that little 2 then would become, oops, that was bad. I'm really struggling right now, guys, I'm sorry. So that 2 would become the subscript in my compound. Let's go ahead and let's look at an example that's a little bit more difficult. Let's look at aluminum and oxide. Aluminum we know comes from the periodic table in the third column, so it's a +3. The oxide comes from oxygen, which is a 2-. So again, if I put one aluminum and one oxygen together, they do not equal 0. So I need to look for the common number between 3 and 2. And so if I look at both those numbers, the common number between 3 and 2 is 6. If I multiply this guy by 2, that gets me to +6. If I multiply this guy by 3, it gets me to -6. And +6 and -6 does equal 0. So now I can go ahead and I can write my ionic compound using those little numbers as my subscripts. So I need 2 aluminums to make my charge 0. So I have Al with a little 2. And I would need 3 of my oxygens to make my overall charge 0. So I have an O with a little 3. So I'm Al2O3. Now you only have to use this trick if your ions have different charges. If I was looking at something that had a +2 and a -2 charge, when you add those things together, it does equal 0. So one of each of those ions would make you a neutral compound. Now let's do one that has a polyatomic in it, the idea of the magnesium phosphate. So again, we've got magnesium, which makes a +2 charge because it has 2 electrons we want to lose. And if we look at the back of our periodic table, we can find phosphate, and his formula is going to be PO4 with a -3 charge. What that means is this whole chunk, that whole PO4 piece, takes on a -3 charge. So again, because 2 and 3 added together does not equal 0, we need to use the least common factor idea again. And because these ions are the exact same as the example we just did, we know that we need to go ahead and get us to 6. So if I take my magnesium and I multiply it by 3, that gets me to +6. If I take my phosphate and I multiply it by 2, that gets me to -6. And +6 and -6 does equal 0. So how do we make this formula with a polyatomic ion? The magnesium's the same. The 3 becomes the little subscript after it to tell us we need 3 of those pieces to make the total charge 0. But this guy, because he's a polyatomic and we need more than one of him, what we're going to do is we're going to put him in parentheses. And by putting him in parentheses, what it tells me is when I put this little subscript 2 on the outside, is that I need 2 of this whole PO4 chunk to get me to my -6 charge. So if you have polyatomic ions present where you need more than one of them in the compound, put the whole thing in parentheses and put the little number that you need on the outside. So it's just about using algebra to go ahead and make your ions a total charge and neutral. And all we're doing in class tomorrow is practicing this idea. So what I'd like you to do on your Google form tonight is please try these 3 examples. This is just a review of naming, so I want you to go ahead and type the name into the box on the Google form. And these 2 are examples of making compounds, okay? Now, I know some of them are going to need subscripts, so they're going to need numbers. Don't worry about getting, superscript, subscript. It's not going to be possible on the Google form. So if you were typing in, for example, the magnesium chloride example, you could just type in MgCl with a big 2 after it. And I'm going to know that means that you wanted 1 magnesium and 2 of your chlorines. For the example we did with the magnesium phosphate, it would look like Mg big 2, parenthesis PO4, big 3. So you can just type it in like that, and I know that you are going to be meaning what I wanted you to show based off what we learned today. So on the Google form, go ahead and try and write those things down. Do your best. I know this is a little bit difficult, so please make sure that you write any questions or concerns that you do have so we can start the class by going over those. And I hope you guys rock this part, so good luck. See you soon.